Welcome back, everyone. This is our second of 8 sessions for our Praxis tutorial sessions. This session will run you about 85 minutes, so I apologize for that, but it will cover periodic trends. It's going to also cover ionic and covalent bonds, so we're still in the chemistry realm here, and then it will wrap up with some electron configurations and how to write those. Again, meteor session, so please make sure that you pause it, rewind it, take your notes, and happy so far. Which of the following properties increases as you proceed from left to right across the same period of the periodic table? Atomic number, electronegativity, or atomic radius? If you don't know, feel free to take a guess because we're going to talk about this in just a second. Ooh. It's a very crudely drawn periodic table, but we'll make it work. All right, I've got some votes being cast. We're gonna decide what the correct answer is in a second. Let's see, 3, 6, 7. All right, I've got everybody. So let's see. Right now we've got a tie between 1 and 2 in 3. So atomic number and atomic radius, or atomic number and electronegativity. Let's see if we can figure this out in just a second. So this is kind of everything I'm going to try to go through today. So I'm going to quickly talk about the organization of the periodic table, families versus periods. We'll talk about the atomic trends that we just mentioned. We'll briefly talk about bonding and how to kind of give names to ionic and covalent compounds. And if we have time, we'll talk about orbitals or balancing equations, but we'll see how it is when we get towards the end of the first couple topics here. So looking at our good friend, the periodic table. You have a really good one on the screen. I have a very ugly one on my whiteboard behind me, so don't judge me. I'm a science teacher, not an artist. Right? Okay. So, anybody know how many columns on the periodic table? How many of these do we have?
8.
8, technically, but in one grouping it's 8, but in total there are
18.
18. So one.
Okay.
Josh said 8. So all of the levels of periodic tables that are up are considered to be our representative group. So the one that starts with hydrogen, beryllium, and then when you look all the way over where the boron family is, the representative group elements are all called the A group. This middle block, so if you look right down here, that middle block of the periodic table is the transition metals. And we call that the B block. Okay. If you count just the B block, then they say 8 rows. So over here with group 13, that's 3A, group 14 is 4A, and so on and so forth. So 8A is technically the 18th family. That's the noble gases. So we've got 18 columns. They call the columns families. We have how many rows on our periodic table?
7.
7. So those are periods. Columns are groups or families, rows across are periods. So 2, 3, 4, 5, 6, 7. I'm glad you said 7 instead of 9, because that means we know that the lanthanide series and the aconite series, these bottom 2 rows, fit into the 6th and 7th period. They've been taken out to kind of preserve the shape and kind of keep the integrity of the periodic table. But right here where lanthanide and aconite is, they actually are number 57 and 89. The periodic table that you get on the Praxis does not have these 2 boxes right here. It just goes 56 to 72. So if you see that weird gap in numbers, remember that the row that you need is right down here on the bottom, our radioactive friends. Now, the families and the rows on the periodic table, elements are not just there randomly. Every element is in its position because of a very specific reason. So every element in the same family, every element in the same column has the same chemical properties. In a second, we'll talk about valence electrons, but that's what determines what your chemical property is, how reactive you are. All elements in the same column have the same number of valence electrons, therefore they have the same chemical properties. So if we look right here, it's listing out some of the major families, the major columns of the periodic table. The first columns with hydrogen on top, even though hydrogen is not counted as one of these guys, it's just there because its atomic number is 1. But the first family is called the alkali metals. All alkali metals are very, very, very reactive. So if you put any alkali metal in water, it will blow up. If you end up teaching high school chem, anybody, there's a really cool video with this guy throwing alkali metals in bathtubs and making them all explode, and the kids freak out from it. There's a safer experiment where you can take lithium and put it in a little thing of water and it inflates a balloon and it doesn't explode, but they like the big ones that we can't do in class. Second family are the alkaline earth metals, a little bit less reactive than the alkali metals, but still pretty reactive in their own way. Jumping across to group 13 or 3A, you have the boron family, carbon family, nitrogen family, and oxygen family. Nothing to stand out about them right now, so that's why they're just named for the element that's at the top. But the next family that has a name is the halogens, group 17 or 7A. The magic number that we're gonna end up talking about in chemistry is 8. So everybody wants to have 8 valence electrons. That means you're stable. The halogens in group 17 all have 7 valence electrons. So your group number tells you how many valence electrons you have. So they're relatively stable, but they do form bonds with a lot of things because they all want 1 valence electron, get to be 8, like the 18th family. So the very, very last column on the periodic table, these are our noble gases. They are inert. Yes, Josh. Yes, valence electrons are the one of the outermost shell. And I'm gonna go through that in just a second for the people who don't know all that terminology, but yes. So the last group right here, our noble gases, are inert, which just means unreactive. But the Praxis likes to use that word inert because we don't really throw that around very often, but it just means they don't react with anything. They have 8 valence electrons, so they do not form bonds. They are stable. The transition metals, we cannot determine their valence electrons, so that's why we kind of skip over them. So when we talk about bonding in a second, we'll talk about what these guys do. But bonding is determined by the number of valence electrons you have and what you want to do with them. So we usually look at the A group guys on the top to determine that piece. One other thing I want us to note about our periodic table is the periodic trends. This ties back to the warm-ups question we just went through. So in your periodic table with its 18 families and its 17 periods, there are very specific trends. The first one is atomic radius. So if you think a math class or anything, radius is determined from the inside of a circle to the outside of a circle, right? That's the radius of something. When you go down the periodic table and you add periods, you're adding rings to your electrons, your elements. So if you have an element that's in the second period, like lithium, because it's in the second period, will have 2 rings on it, just like that. But if you had somebody like, who's farther down the table? I need to look at a name. Barium. Barium is in the 6th period. That means barium has 6 rings around it. It's getting away from my lithium. Lithium with its 2 rings has a nice small radius. Barium with its 6th rings, because it's in the 6th period, has a very large atomic radius. So as you move from top to bottom in the periodic table, the radius of all of your elements gets bigger. So the closer you are to the bottom of the periodic table, the bigger your atomic radius. The closer you are to the top, the smaller you are. The other 2 trends that you have here are ionization energy and electronegativity. Those go hand in hand. Ionization energy is the energy required to take away an electron for something, therefore making it an ion, what we talked about yesterday, that has the positive and negative charges at the top. Yesterday we saw Ca2+, calcium 2+, and we said that means it lost 2 electrons. Calcium also has a low ionization energy. It's easy to take those electrons away from a calcium ion. Electronegativity is how clingy an atom holds on to its electrons, so they go together. How easy it is to take them away and how hard it holds on to them, those are the same trend essentially. The smaller you are, the easier it is to hold on to your electrons. So that means if you have a very big radius, like something in the 6th or 7th period, you have a low ionization energy and electronegativity. It's easy to take away some of their electrons. However, elements that are over here, higher on the periodic table and farther to the right, which are the smaller ones, have the highest electronegativities and ionization energy. I know this one's not labeled, but right where my mouse is fluorine, which is the top of the halogens, so it's very far to the right, second to last column in the top row. Fluorine has the highest electronegativity of any of the elements on the periodic table. When we talk about electronegativity, we can't really talk about the noble gases because they don't lose their electrons, so they don't really count. But the way I always teach my students to kind of remember this trend is to remember that fluorine is the highest electronegativity, smallest radius. Now, usually giving them a focal point will help them remember where the trend switches. So fluorine is the smallest with the highest, and down here you have cesium and francium. They are the biggest with the lowest. That's how I always tell my students to remember it. Questions on the test like to ask you like what the trends mean. So to kind of give you a visual, and it can sound kind of silly, but this is also how it's easy to remember. So one of my favorite foods is donuts. I'm from Boston, where Dunkin' Donuts originated, and I really like old-fashioned donuts. They don't taste like anything, but I like them, whatever. If I was a person who had 17 boxes or 7 boxes of old-fashioned donuts, it would be relatively easy for somebody to come along and take a box away from me, right? I can't hold on to all of that at the same time. So if I have 7 boxes around me, that means I have a very large radius, but it's hard for me to hold on to all of my donuts. However, if I'm somebody like fluorine and I only have 1 box or 2 boxes of donuts, it's very easy for me to hold on to those. Therefore, my small radius makes my electronegativity higher. Does that make a little bit of sense? Hopefully. I learn things best through analogies, so hopefully that will help somebody. When they talk about the trends, so let's come back to our question from the warm-up. When we had our poll question, most of the answer choices were from B and C. So I'm glad that we eliminated A, because radius does what as you move from left to right? Do atoms get bigger or get smaller?
They get smaller.
They actually get smaller, so 3 can't be the answer, which means which other ones can we eliminate?
C and D.
C and D. If we know that atomic radius decreases as you move from left to right, then the only answer that can work is B. The atomic number and the electronegativity will increase as you move from left to right. Cool? So luckily, the Praxis and the CMS standards for science are pretty aligned in terms of content. So these are the same trends that you'll have to teach your students, whether you teach high school or middle school science. This is the exact 3. There are more trends to the periodic table, like they'll talk about metallic character and all that stuff, but the 3 that our kids need to know and that we need to know for the test are electronegativity, ionization energy, and atomic radius. Couple other things to talk about with our good friend, the periodic table. Oh, look, I forgot there's one more question, my bad. Another check for understanding. So this diagram represents atoms from the halogen group. Anybody remember which group of the periodic table is the halogens? What number?
Fluorine.
17.
Good, I hear 7, 17, and I hear fluorine. All correct. There we go. On the basis of relative size, which of the following correctly lists the atoms from the top to the bottom of the group? So this is talking again about radius. Which one would be the top? Good, I'm seeing some right answers in the chat. Yay. So in the chat, I'm seeing D as my answer, and I agree. If we're going from top to bottom, that means we're going from smallest to biggest. So it would be D, C, B, and then A, because they get bigger as you move down. This is the radius question. Anybody have questions on the trends there? You guys are awesome. Okay. Looking at our periodic table one more time, the next thing I wanted to talk about is that magic number again. So 8. Everybody wants 8 valence electrons. So in the chat, Josh mentioned that valence electrons are your outermost electrons. I should have brought an eraser home, but I didn't. So yesterday we said that the atomic number tells you the number of protons and it tells you the number of electrons. So if we look at the periodic table, beryllium is what number?
4,
Beryllium's number 4. What period is it in?
2.
2,
2. So if it's in the second period, how many electrons should it have? I mean, how many rings should it have? I'm sorry.
2.
2.
2 rings. 1, 2. If its atomic number is 4, how many protons should it have?
4.
4. And how many electrons?
4.
4. Now, because it's in the second period and it's in the second column, it should also have 2 valence electrons. The column that you're in tells you how many valence electrons you'll have. So if I were to draw a Bohr model of beryllium, I would give it 2 electrons in the middle ring, and then I'm going to give it 2 electrons in the outermost ring. These outermost ring, those are your valence electrons, and these what determine your chemical property. So same example, let's see. Fluorine, let's do sulfur. No, let's do fluorine. I'll put a drawing one. What number is fluorine on the periodic table?
9,
9.
Fluorine's number 9. What period is it in?
That would be halogen.
2,
There you go. It's in the halogen family. Remember, period is its row, though. So what period is it in?
It's in 2.
It's also in 2. So what number is fluorine again?
9.
9. How many protons would it have?
9.
How many electrons?
9.
9. Right? So both beryllium and fluorine are in the same period. Both have 2 rings. It's got 9 electrons. So again, I'm going to put 2 in the center. The first ring can only hold 2, so we can't do any more there. And then I'm going to give it how many on its outside if it needs 9? How many left? How many will I have left?
Oh, you would put 6, right? Because
If 6 plus 2 would be 8, so I actually need how many?
7.
7.
Because can the second shell hold as many as 8?
Yep. Right? I've got 7 electrons in its second shell. Fluorine is in the halogen family. What number are the halogens?
After class, I'll fix you some cereal.
7A or 17.
You weren't when I tried to feed you earlier, so now you gotta wait for my class. Put that back in the dirty clothes because it's dirty.
There we go. So halogens are group 7A. That's why they also have 7 valence electrons. So if you draw the picture, it'll show you how many electrons. Or if you look at column number, it tells you how many electrons are in its outermost shell. Okay. So nitrogen is in the 5th family, 15. It's got 5 valence electrons. Make sense?
Yes.
This is important for bonding. So when we talk about chemical bonding, it's all about how many electrons you have in your shell, who's got what, who's going to get rid of them, and who's going to take them in. So real quick, if we look at the periodic table, every time you have valence electrons, it's going to give you something called an oxidation number. So how many electrons you have to gain or lose tells you your oxidation. So Elements are going to do whatever is easier. It's going to do whatever is going to take less work. So everybody in the first family has how many valence electrons?
1.
1. Do you think it's going to be easier to lose 1 or gain 7 electrons?
Lose
Lose 1.
Uh-huh.
It's way easier to get rid of 1 electron than to go bumping around trying to find 7 more. So everybody in the first family has an oxidation number of -1. They're going to give away all of their electrons. I'm sorry, 1 plus. Because if I give away a negative, I have a positive charge. So everybody here has a +1 charge. The second family, they all have 2 valence electrons. Is it easier to give away 2 or gain 6?
Give away 2.
Give away 2. So if I give away 2 electrons, what should my oxidation number be?
+2.
+2. +2. We're going to skip the transition metals for now because they don't form easy oxidation numbers. But we're going to move over to group 3A or group 13. So same question, they have 3 valence electrons. Do I give away 3 or take on 5?
Give away 3.
You give away 3, so this is +3. What do you think will happen with the next family?
Break even.
They break even, so they have 4. So they can go either way. It depends on what they're paired with. So we say that they are plus or minus 4. They can either gain 4 or lose 4. It depends on what they're attached to. Now you'll see in a second that it's going to kind of form a pattern. So the nitrogen family has 5 valence electrons. What do you think they're going to do?
Take 3.
They're going to take 3. So that means they're going to have a what charge?
-3.
There you go. -3 oxidation number. So if you look, you see it's 1, 2, 3, 4. The trend goes the same way on the other side. This will be -3. This is -2, -1. And then what happens with do they need to gain or lose anything?
No.
Nope. So they have an oxidation number that looks like a rhombus, but that's supposed to be a 0. Sorry.
That's all right.
So oxidation numbers are how many electrons you can gain or lose. That's the same thing. We also call that its charge. On a test, sometimes it'll say something has an oxidation number of 6. If you look at this up here, that's not possible. So anything bigger than an oxidation number of 4 is not something that we can do, because that means you would be taking on 6 electrons and nobody does that. So now, just to make sure we're on the same page, let's look at a quick check for understanding. Does anybody need me to slow down or repeat anything?
Can you repeat one more time?
Yeah. How many electrons you can stand to take on or give away is your oxidation number. So it's depending on how many valence electrons you have. The nitrogen family here has 5 electrons. It's going to be easier for them to pick up 3 than to try to get rid of all 5 of them. So they have an oxidation number of -3 because electrons have negative charges. Does that make sense? Because everybody wants to get to 8. 8 is the magic number.
Okay. Okay.
Metals, especially in these first 2 families, give away all of their electrons and lose a ring and will still have their 8 electrons if you draw them out in a Bohr model.
Okay.
Quick question. Which of the following elements is correctly paired with its most likely oxidation state? So to do this one, you would technically need to look at a periodic table. So I'm going to flip back to the previous screen in just a second. I'm going to have you guys look at the choices. So it says, does oxygen have a -2? Is magnesium a +1? Is sulfur a +4? And silicon or +2? So it's asking you to look at those 4, oxygen, magnesium, sulfur, and silicon, and determine what their oxidation charge is. So if we have, We're going to just highlight it for folks a little bit. So we've got oxygen, magnesium, was it sulfur and silicon?
Mhm.
Sulfur and silicon. Magnesium is in the second family, so what is its likely oxidation number, guys?
+2.
+2. It's going to give away its 2 electrons. Oxygen and sulfur should have the same oxidation number, and it should be what?
-2.
-2. They have 6. They want 2 more. That's a 2- charge. And then we have silicon over here, which is in our favorite family. That is the
+-.
plus or minus. Oh, Josh, I just saw your question about the 14th family, about nonmetals and metals being there. Yes, ionic bonding, if they're bonded to, it depends on what they're bonded to. So they can form ionic or covalent bonds depending on what's present. So that will determine if you're going to do something with their oxidation numbers or if they're going to share their electrons covalently, and then the oxidation numbers don't matter. And that's the next thing I'm going to talk about in 2 seconds. Let me clear this so we can look at that question one more time. There we go. So based on what we just reviewed, gracious, what is the correct answer? Which of the elements is with its correct charge? Ooh, somebody is on it in the chat. You guys are just, oh, y'all. Yes. Y'all, I wish my chemistry students picked this up as fast as y'all, because teaching chemistry would be a breeze. The answer is A. All the rest of these guys are wrong. Okay. So before I finish up with, well, one of the topics, because there's 2 more things to talk about, I want to give you guys a question and see if we can figure it out before I give you the answer. And it's going to kind of talk about these electrons that we've been looking at. It says metals conduct electricity very well. Which of the following properties of metals accurately accounts for this observation? So why do metals conduct electricity well? If you're not a chemistry person, try to use process of elimination, because one of these is wrong right off the bat. So I see people pondering. I'm going to teach one thing real quick and come back to this question to see if we get it now. So I see some people in the chat. I see a couple answers. Let me teach you something real quick. So in order to answer this question effectively, you have to know a couple definitions, because actually right here, A, B, C, and D are giving you the definitions of some of the bonds. So on your periodic table, you have metals, nonmetals, and a couple things called metalloids, which are metals and nonmetals kind of mixed together there. When you have a metal and a nonmetal together, you form an ionic bond. This involves a complete transfer of electrons. So if I could add a couple words up here. Ionic bond means we transfer, the metal is going to give away its valence electrons to the nonmetal. If you have 2 or more nonmetals mixed together, or a metalloid and a nonmetal, you have formed something called a covalent bond. And in covalent bonding, you're going to share your electrons, which means neither one of the elements that you have in your compound is going to completely give away its electrons to the other one. They're going to share collectively to get to 8. Now, the only one we don't have up here is a metallic bond. So if you have 2 or more metals, you have formed a metallic bond. And it's a little bit unique because that middle block that we've been skipping over in terms of the oxidation numbers, those are transition metals. transition metals have a sea of free floating electrons. So their electrons are what we call delocalized. They're not housed in specific valence shells. They don't have a specific number of valence electrons. So when you have two or more metals that bond together, they kind of just pick up the electrons as they go. It's not a transfer, it's not a share. It's literally like we bump into and we grab, a bump and grab, like a robbery. So now if we go back to that question, and I see some people writing, so I'm gonna give a couple more seconds before I leave here. With this in mind, that last question, if you just know the definition, should be a lot easier to answer. Is it okay if I switch? Unfortunately, I have to clear the screen to go back, but nope, I don't want that. There we go. So looking at this one more time, if it's talking about metals, process of elimination, which one can we get rid of right off the bat?
D.
D. Because we know two or more metals cannot make a covalent bond. That would be non-metals only. Wow, I can't write all with the mouse. But now we have A talking about electrons being transferred, B talks about them being shared, and C talks about a loose network. Based on what we just learned, thanks Matt, I see you. Yeah. The answer must be what, guys?
A.
Careful. Remember the keyword here?
C, because it's a bump and grab, like you said.
Yep. If we're talking about metals only, then the answer has to be
B.
B.
The transfer is the ionic bond, correct?
Yes, it is. And sharing would be who?
Covalent.
Covalent. So valence electrons being transferred again, this would have to be, come here, text box. Doesn't want me to write. Okay, guess I can't do together. Sorry guys, I'm not very good at Zoom, so I'm learning as I go. But if we're talking about transfer like this box right here, that would have to be metal plus a non-metal. So that we'll talk about how to do that in just a second. I spelled metal wrong. If it's talking about sharing, we just said sharing is covalent, so that must be two or more what?
Non-metals.
Non-metals or non-metals and metalloids.
Yeah.
And then if we again have just the sea of free-floating network electrons, this is a metallic bond, which can only happen between metals.
The transition. That's only the transition metals, right?
It could be a main group element in a transition metal, but just long as it's metals only.
Okay.
Let me see, 7:38. We are good on time. Is everybody all right? I'm talking a lot, so if anybody needs me to slow down, please tell me to. I'm also recording the session, so if it's just something you want to go back and listen to or see an example again, got you. So we just talked about this. Now we need to talk about how to name them. This flow chart looks a lot more complicated than it is. Okay. So all you need to do, so if it gives you a formula and it wants you to write the name of it, you have to just think about the two pieces that we've already talked about. You have to be able to identify if it's a metal or a non-metal. Therefore, so it'll tell you if it's ionic or covalent. If you determine that something is ionic, so the very first one that you see is a metal, the second one is a non-metal, you're going to do something, what we teach our kids is called swap, drop, and chop, which means you look at their oxidation numbers, which are their charges, you swap them to the opposite side and make them a subscript. And that's how you take the name and change it into a formula. If you have to go back the other way, you just write down the name of the elements and change the ending to "ide." So putting it in an example would be something like this. So say on the test, they give you sodium bicarbonate. First thing we have to do is look at sodium. Sodium, even though people often forget, but sodium is a metal. It's in the second family, like second column down. I think second family, second element is sodium. So if I have a metal, and then I have something called bicarbonate, which is actually polyatomic, so it's a little bit different. last little asterisk, sorry. If the ending is not IDE, like fluoride or chloride, if it's ate or ite, then it's polyatomic, and they're gonna have to give you a chart to tell you what the charge is or the oxidation number. But if it ends in ide, fluoride is just fluorine. So you can look at the periodic table and say, okay, it's in group 17 minus 1 charge. But again, if it ends in ate, ATE, or ite, ITE, then it is polyatomic, and they're gonna have to give you a list. They don't expect you to have all the polyatomics with their charges memorized. Now, if I wanna write the formula for sodium bicarbonate, I look at the first one, say sodium is a metal, bicarbonate is not a metal, so this has to be ionic. If it's metal and something else, it's gotta be an ionic bond, right? We just learned how to determine the oxidation number of sodium. So if you look at a periodic table, and I know some people don't have one, so I'm gonna go back to it. Sodium is right here. What is its charge?
+1.
+1. So if we have sodium bicarbonate, we say sodium has a 1+ charge, right? Bicarbonate means it's going to be on a list. So if I look at this list here, it says the formula for bicarbonate is HCO3, and then it's just got a minus sign. In chemistry, we don't like to write ones. So if you just see a minus symbol, it means -1 or +1. The 1 is understood. So now you've got your elements listed. To finish this, all you're going to do is swap ones. So we're going to give the 1+ to the bicarbonate. So I put this in parentheses. I put a 1 down here. Bye. I take the 1- and I give it to sodium. Remember, we don't like to write ones in chemistry, so we actually going to get rid of them. And so the formula for sodium bicarbonate is NaHCO3 after you get rid of the charges.
And we couldn't hear you.
Yeah,
Oh,
something
I'm sorry.
happens when you have that up against your face and it gets really choppy.
I'm trying to learn how to like navigate this thing. Because writing on the screen is awful.
When you started switching numbers is when we kind of lost you.
Okay, I'm gonna do another one and try to stay like this. Is this a little bit?
The microphone's very directional, so when you go off to the side, it loses your voice.
How about here?
That's
Am I
better.
Okay. We're gonna make it work, guys. This is all part of teaching. So let's do a different example. The last one up here we have is iron 3 chloride. Is iron a metal or a non-metal?
Metal.
A metal. Now, if we look back at our periodic table, iron is right here. How can we determine iron's charge? Ooh, we didn't go through that one just yet, right? Luckily, we don't have to figure it out. Right here, it gave me a parentheses with a Roman numeral. If your metal is in the middle block, if it's a transition metal, the charge is going to be indicated by this Roman numeral right next to it. So if we have iron, its charge is going to be what?
Well, obviously 3, right?
3. Hint, the metal is always going to have a positive charge. So it's going to be iron 3+. Chloride is chlorine. So if we look back at our periodic table, chlorine is right here in group 17. If it's in group 17, what charge is it going to have?
-1.
So -1.
Now we're going to do the swap, drop, and chop. So now I'm going to take the ions and I'm going to swap them to the other side. So I'm going to take iron's 3 and I'm going to drop it to the bottom of chlorine and I'm going to get rid of its symbol. I'm going to take chlorine's 1 and give it to iron, and I'm also going to drop the symbol. What number can I get rid of?
The 1.
So the formula for iron 3 chloride is FeCl3. I feel like a game show host trying to get that up there. Does that make a little sense?
What's the mnemonic again? It's swap.
Drop and chop.
Great. Thank you.
Also, for my people who might end up teaching physical or chemistry on the high school level, our kids love swap, drop, and chop. There's a song called Pop, Lock, and Drop It. They like to say, swap, drop, and chop it. Swap, drop, and chop it. It's a little corny, but it works, and they remember.
So I understand why we dropped the 1 because it's just a 1.
Yes.
But in the previous example, when we did the sodium bicarbonate, in the end, your sodium still had a plus sign.
It shouldn't have. It should have been
Just the sodium. Okay.
Yeah, I probably forgot to erase it all the way, trying to get this away from me. Okay on that type of example? So let me see. This is going the other way. So this is Na is a metal, chlorine is a non-metal. If you see them, so if it says formula and it wants to know the name, you're just going to write out the name of the metal. So Na is just sodium. And then you take the non-metal and you change the ending to IDE. So chlorine becomes chloride. NaCl is sodium chloride. Bonus question, does anybody know what sodium chloride actually is? It's common name.
Salt.
Yep, because you guys are brilliant. You don't need me. Table salt. That is a question they like to ask you all the time. They'll say sodium chloride. They bring it up a lot in the life science section. They'll talk about hypertension and high blood pressure. And then instead of saying salt, they'll say sodium chloride, and you'll think it's like some big complicated problem. We all know salt deals with blood pressure. Like it gives you high blood pressure. The last 2 up here, if you see something in parentheses, that means it's probably also polyatomic. So they'll have to give you a chart similar to this one. And all you have to do is write down the name. So OH, if you look at the top of our chart, is hydroxide. If you have copper and hydroxide, this 2 came from the copper. So this is copper 2 hydroxide. Copper, the only reason I had to say copper 2 is copper is a transition metal. It's in the middle again. So I have to tell the charge, and the charge is over here next to my hydroxide. You only do that, the Roman numerals, if the metal is a transition metal. If the metal is not transition, so if it's in the first 2 columns, Roman numeral.
So that would be copper parentheses 2 in the middle and then hydroxide.
Yes. Is magnesium a regular metal or a transition? Let's look. Magnesium's here. Is it regular or transition?
Regular.
Regular. Do I need to put the charge in Roman numerals?
No.
No.
No. Only if it's in this middle block here. So if we look at that last example, I'm just going to say magnesium, and then I see NO3 is nitrate. So this is just magnesium nitrate, not magnesium 2 nitrate, because magnesium is not a transition metal. Now remember, this swap, drop, and chop and having to find the oxidation numbers is all compounds, metal and non-metal. If you have a metallic bond with 2 or more metals, it's just named after whatever metals are in there. So if you have zinc and zinc put together, it's called a zinc alloy. You just put the word alloy at the end. If you have copper bonded to copper, it's copper alloy. That's it for metallic. The last one we're going to cover before we run out of time is covalent, which is 2 or more nonmetals. I think these ones are a little bit easier because you don't have to do any swap, dropping, and chopping. The only thing you have to remember are Greek prefixes for numbers. And most of them we've seen probably over and over again. So for an example, and I'll come back to the slide towards the end if anybody wants to copy this down, but I'm gonna do the same thing, just kind of teach it through an example. So right here, I have disulfur tetrafluoride. I know this is covalent because if I get rid of the prefixes, I see sulfur and I see fluoride, which is sulfur and fluorine. Those are both nonmetals, so this has to be covalent. To write the formula, I'm gonna look at the first one. So anybody know what the symbol for sulfur is?
Just
It's
F.
just S, isn't it?
It is, it's just S. Di means how many?
2.
2.
2, so 2. The symbol for fluorine is
F.
L. Oh, just F.
just F. I used to say FL forever, but it's just F. And then tetra. Anybody know what tetra is? How many?
4.
Tetra is 4.
Oh yeah, that's much easier than the other stuff.
And the beautiful part here, so the chop in the ionic section means reduce it down. So if this was ionic, it would have to be simplified. But because it's covalent, we keep it as it is. We don't have to simplify anything. So it's just S2F4. So if we did carbon trioxide, carbon and oils, do we have a prefix on the carbon?
No.
No. So just like the number that we don't like to write down, if there's no prefix on the very first one, we can assume it's how many?
It's nothing. It's 1.
Just 1.
Itself.
So carbon trioxide would just be CO tri is 3. So carbon trioxide is just CO3. This right here is called the mono rule. So with covalent compounds, you never put the prefix mono on the first element. You can put it on the second one, but you would never put mono on the first element in a covalent compound. You guys actually already know that, because if I showed you what's the name of this covalent compound? 1 carbon, 1 oxygen.
Did anyone hear the question?
My bad. If you have 1 carbon, 1 oxygen, what would the name of it be?
Carbon monoxide.
Yeah, we already know carbon monoxide. We've never say monocarbon monoxide. That's too much. So the mono rule says you don't put mono on the very first element. Make sense?
Yep.
So it's 7:53. I'm gonna move us ahead to a check for understanding question just to see how we're doing. I'm gonna give us about a minute, see if we can answer this one. And then in a second, I'm gonna put up a hint on the screen because I did not put the hint that I was supposed to. Phosphate, right? PO4. Minus 3, right?
Right.
Yeah,
-3.
I had to think about it. Phosphite is -2, so I was thrown off there for a second. Okay, gotta. Remember, so first thing to think about, is this ionic or covalent? Is tin a metal or a non-metal?
Metal.
Tin is a metal. So it's telling me tin to phosphate, right? So I'm not gonna talk it out. I'm gonna write it out on the board since I know I can't talk and write at the same time. And then I'll explain it if it still doesn't make sense. Because I saw in the chat, C as an answer. Let's double check and make sure. That's my beginning. I've got tin with a 2+, and phosphate, which is PO4 with a 3- charge. When I swap drop, I gave the 2 from tin to phosphate. I gave the 3 from phosphate to tin. So the correct answer one thing to note. So the correct answer is C. You don't have to reduce, even though there's a 4 and a 2 here, we put the polyatomic inside the parentheses to know that you don't have to touch anything in there. So phosphate should always stay PO4. You never make it PO2. So the correct answer, my friends, should be C. So electron configurations are a way to essentially tell the location of an element based on its electrons. So in order to do that, you're going to need to know a couple things. You're going to need to know first how to identify the elements on the periodic table, and you're going to need to use their atomic numbers, which is the top one. Then you're going to need to know the order of the sublevels. So I'll send you guys a document to show you what the periodic table looks like, but it's broken up into 4 different blocks: the S block, the P block, the D block, and the F block. So since we're talking about it, I'm going to show you now. Each of those blocks can only hold a certain amount of electrons. So you see up top where it says S can hold 2, P can hold 6, D can hold 10. And unfortunately, the F block is not on there, but the F can hold up to 14. Each of those again, so if I looked quickly, if this was the periodic table, this is what it's referring to. So the S block would be the first 2 columns. The P blocks would be groups 13 through 18. The D block is that middle section of the transition, and then the F block are the 2 that are pulled out on the bottom.
Okay.
S, P, D, and F.
Okay.
The number of elements are also how many blocks or how many squares in that particular section. So you see that the S block is only 2 elements across. That's why it only holds 2. The P is 6 elements across, which is why it holds 6. If you counted the D, it would be 10. And if you counted the F across, it would be 14 elements across here. So on this screen, this little weird looking triangle diagram is one way to know the order of the elements and also how they're filled in. So you can learn how to do electron configurations a bunch of different ways. Essentially what you do, so if you use this method, you'd have to remember, okay, 1s, 2s, 2p, 3s, 3p, and so on and so forth.
So go on
But you
order.
have to remember that it's filled in diagonally. So the order, if you read it left to right, that's not the order, it goes diagonally across. So if you were to fill in the orbitals, the order would go, and I want to draw on the screen. So the correct order would be it goes 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s. So you always start here and move down, and that's telling you the order in which the sublevels get filled up. So when you want to write an electron configuration, you have to take all 3 of those pieces of information, the atomic number, the order, and how many elements, and you put them all together. So if I wanted to write the electron configuration for aluminum, I would need to know that aluminum has 13 electrons. So when I'm trying to fill up this order, I have to use the order of the sublevels and count to number 13. So when I completed it, its electron configuration would look like this. The number in the letter represents the order of the sublevels, and I take how many elements each sublevel can hold and make it look like an exponent. If you added all of these numbers up together, you would get 13.
Okay.
So 2 plus 2 plus 6 would be 10. 10 plus 3 is 13.
13.
This is just one method to do electron configurations. The other way is you can memorize where they are on the chart and map it out. Or I have this order memorized, so I know 1s, 2s, 2p, 3s, 3p, 4s, 3d, just from practice, and that's how I do electron configuration. But let's do one. I'm gonna do a couple of them full out so you can see how I would map that out. So my next example is silicon. The number that I need to remember, what number am I gonna try to get to when I do my electron configuration?
14.
14. So that means silicon has 14 electrons. And when I draw my electron configuration, that's what I'm gonna try to get to. So to do my electron configuration, I'm gonna start at the beginning of my little pattern. And I'm gonna say 1s, 2, because every s holds 2 electrons.
Okay.
I start back over on my next row, and the only thing there is 2s. So next I have 2s, 2. Right? How many electrons have I used already now?
4.
4. And I still have 10 more to go. So starting at the next row, I now have what?
2p, 3s,
2p, but don't be afraid. P is hold how many?
6.
6.
Good. So now I've got 10, right? My exponents add up to 10. So how many more do I need?
4.
4.
4. So after 2p would be,
The 3s.
yep, 3s, what?
Well, not squared with 2.
Yep, 3s2. And I'm almost there. I'm up to 12 electrons.
So
I
you
will
need 2
start
more.
here. And I go to
3p.
what's the next one? Yep, 3p, and all I need is what?
2.
And that's its electron configuration.
Question.
Yes, ma'am.
All right. On the left-hand side, you got the S.
Mhm.
In the middle is D. Where's P?
P is
F
the,
on the periodic table.
Would that be 13 through 18?
yes, 13 through 18 is the P block. So Miss Simmons,
And then the F is down at the bottom.
yes, ma'am. Those 2 rows that look like they've been taken out.
But they're not.
Right.
Okay.
Okay.
3.
I know our time is 7:30, so what I'm gonna do is I'm gonna drop the exit ticket for those that need to leave. If anybody else wants to still practice, I'm going to leave this practice screen up right here. So for those of you that want to stay on and practice this a little bit longer, I'm gonna leave this on the screen so we can practice together. But I know I want to respect everybody's time. So let me give the exit ticket for those that need to go. Please make sure you do the exit ticket. That is how I count the attendance for our session. Some of the questions for this one, there might be a half-life question on there because I was going to teach half-life instead. So let me make sure. If not, yeah. For this one, if you don't know the questions, it's okay because I ended up teaching this and I didn't have time to change the questions, but just make sure you try your best. They don't count for credit again, they just count for attendance. So there's the exit ticket in the chat for anybody that needs to go. For anybody that needs to stay on a little bit, I want us to try to practice these problems that I have up here. And I do want to put that order back on the screen too to help.
Sulfur. So if you have 16. Good. 16.
You're welcome, Anna. Thank you. I believe it is Anna, but let me just double check. Thank you, Bryson. Thank you for attending. Boy, who are you telling no to? Anna. Yes, Anna, you are all set. This is your 8. Thank you for attending and congratulations on passing. I'll see you in the summertime.
Made a little cheat sheet of some more stuff I remember. So I'll wait till we finish.
And you got this next time.
Yeah, because I'm one of them people, I missed it, but my memory good about what was there and what wasn't there.
I took all my notes. What's up?
So how did you do? I only missed it. I did way better than I thought.
Really?
More than I thought I did. I only missed it by, I think, like 30 some points. So I'm not going to say that's not bad, but science, I have no science background, so I'm going to take that.
Yeah.
Me.
At least you took it. That way you know it's on there.
Yeah. I didn't have any of these on mine. It had, it's like Forest Central something. I don't know how to say it. Hold on. I wrote it down.
Thank you, Justine.
Did they have anything about the clouds? Because I've been looking at them clouds.
I can add some clouds.
Well, put it on there then.
There was like only one question, and I don't think it was even asking about clouds in the test.
What is the stratosphere? I remember the stratosphere and the troposphere, and I felt like a dummy when after I finished.
Airplane.
It used to be a song when I learned in middle school, but I can't remember, but it was like, was it stratosphere, mesosphere? And I think it was like thermosphere, exosphere, all in the atmosphere.
I like that already.
But I can't remember the order. I remember mesosphere because it was the middle. But it was like all in the atmosphere.
So I went to observe my teacher today, and she has not taken her test, but she's been teaching for 4 years. So I'm like, why did they not give us that option? Why did they not give us that option? She said she was originally supposed to be elementary.
I had a friend like that too. And
what's her degree in?
She said history.
So were you observing her in a history class?
No, it was middle school science, 8th grade. Yeah, she said she was originally supposed to be elementary, and they let her teach 8th grade.
Yeah, like my friend was like that too. Can y'all hear me?
Yeah.
Oh yeah, my friend was like that too. Like she couldn't pass the Praxis too, and she had already like finished up everything, but like she could teach, but they wouldn't let her graduate. You know what I'm saying? But she had a teaching job before she actually like passed it, and I was like, well, that's kind of weird, but okay.
Destiny, she might have got in there when licensure was in like a weird period. Because when I came in, we had to pass 2. We had to take the Praxis before we could come. And then it was like weird for a couple years where they were giving people that grace period. But what they were finding was that a lot of people weren't taking the test or weren't passing the test, and then they weren't getting their licenses. So she might want to watch out, because if licensor checks her or she tries to transfer, she's gonna run into a problem with her license.
But honestly, I think that's kind of better because she's learning while she's teaching.
Oh yeah. Oh, I feel like I got a 152 when I took the Praxis, so I barely passed. I had no science background. So I feel like if I took it now, I'd be like,
yeah. I mean, it's possible,
anyway,
but I think it's kind of stressful being that we don't have science background.
Yeah.
And we trying to pass this test before.
Under stress before June 1st.
Yeah.
Ever.
Which 100%.
Isn't it May the 11th? We have to.
Somebody put it on Facebook. It's June 1st.
Oh, okay.
I forgot her name, but she put it on there. So June.
Wait, when the last time to take the test?
Yeah, before you have to post your final scores.
Yeah, but I saw someone post something about like it had to be on May 11th.
Yeah, that's what I thought too.
Check Facebook. Somebody just asked today and she answered it. It says June 1st.
Okay.
Yeah, she put it on Facebook.
So you can take the test all the way up to June 1st?
Mm-hmm.
Oh, see, I thought the cutoff date was May the 11th.
I thought so too.
No.
I thought so too.
But okay, when I went in, it was okay. If I don't pass, don't beat yourself up about it. At least you're gonna know what's on it. It gives you 21 days, so you can take it again in 21 days.
Yeah. So it gives you 3 weeks to brush back up, which means I'm confident if y'all don't pass it the first time, I know y'all will pass it the second.
I just like, it's killing me because I'm like, I don't know if I'm understudying in somewhere or overstudying in certain areas.
I will tell you for middle school, know that chemistry and that physics and them definitions.
So for the high school, I would say know your physics, because for mine it was a bit physics heavy. Know a bit more of your chemistry and know your biology, cellular biology.
Biology too. Yeah, biology too.
I told that last time. I said, make sure you know them cell structures.
Yeah.
As soon as you said that, and I did not look over that this morning, and there was like 2 questions that asked about that. But I was real like confused as to why they kept asking.
But the physics, were the physics questions like the physics formula or just no physics, period?
The stuff I ran into was mostly wavelengths, light, and there were probably a few test questions that were like experimental questions they threw in there, because I would not have known the answer to a few of those.
And that's a good point too. You might encounter some field test items, which would be questions that don't count to your score. So if you see a question that's like, that is hard, who would know that? There's a good chance that it's a field test.
Yeah, or if it's asking something extremely specific. In my case, it was asking about something with fiber optic cabling and how it does vision or something like, or how the wavelength passes through it. And I'm thinking, I don't know this. This is extremely specific too.
Right.
Yeah.
So you said cell
And then with the physics, was there any formulas on there? Oh no.
Those formula sheets, I'm sorry, Miss Simmons. I might use the word trash, but they were trash.
Really?
Yes, ma'am.
So we gotta memorize all these formulas.
Okay, what I did, I made a cover sheet. Because they give you like a booklet. It's got basically 4 pages. So you put 4 pages up, make a cover sheet. So each session I'm doing now, I'm just adding to my cover sheet. And every night I'm writing it twice. So I can just look at my sheet and go about my business.
Okay.
So yeah, for the high
You
school.
say a cover sheet. Like, what do you mean, like cover sheet?
In high school, when we took the math EOC, our teacher, she gave us a piece of paper. We knew to make the cover sheet. It gave you all the formulas you would need, like little acronyms that'll help you along the way. Just little, like a cheat sheet, but it's not cheating.
Okay.
So they let you do that?
I did. I mean, it was my brain, my piece of paper. So.
Oh, okay.
Oh, yeah.
And you can make yourself like a reference table when you get in there because they give you some paper.
Yeah.
Oh, okay.
You can't take nothing. They checking your shoes and everything.
Okay. So, Sam, what were you saying?
So for high school, know your cellular biology. It's only like what 20-25 questions, but know your cellular biology. Just know that in general. Like,
Miss Simmons, don't drop your head.
environmental.
You got it.
Know your
Ma'am.
physics. Know your
Don't
chemistry.
drop your head, Miss Simmons. You got it. Don't do it. You got it.
I know I got it. That's why I'm looking at this stuff going, okay.
Yes, you got it. You got it. You got it.
Thank you, Sam. Thank you,
You're
Chelsea.
welcome.
You are.
I'm getting ready to go to bed.
I take my test Thursday. I'm nervous.
You got it. You got it. You got it.
You have an exit ticket from last time, right?
Yes, ma'am.
Okay. So I will see you tomorrow. I will email you all that good stuff. I love y'all. Thank you very much. I'm going to sleep.
Have a good night.
Bye.
I was going to try to do the predict electrons, but my brain is saying, that's what I said, I'm stuck.
Okay.
Oh, Sam. Oh, sorry. Go ahead, Destiny.
The first one.
But the sulfur?
I think it's, what is it? Selenium or something?
Amir.
Yes, sulfur.
The sulfur one would look like this, Miss Simmons.
Yeah, sulfur.
Okay, let me look at this. Okay, the one we was doing together, that had kind of confused me because I'm like, how in the world you get that answer? I had took a picture of it, so let me go back.
Also, let me send you a video too, Destiny. That like where I got those screenshots from is a YouTube video that's really helpful with it.
Okay, because I'm like, really?
Let me give you, where is it at? Sam, for the question that you asked me, so if anybody else is high school, remember that you have to take like a principles of learning and teaching test too. Sam asked, one of the questions was about the child who comes in hungry with bruises. Was one of the options report?
One of the options was call like DSS. The other one was talk to a teacher, talk to the student more, or call the parents. and
Huh?
I didn't know which one to pick. I picked the DSS one.
Social
No, I
work.
think you're supposed to call the parent.
You supposed to call DSS. I'm a social worker.
What was the question?
Oh, okay.
We're gonna want you to report that because you have duty to. It's like duty to warn type thing. So
Yeah.
Oh, Chelsea, you a social work major?
Okay, so you're supposed to call the parent?
Me too.
Wait, what was the question?
What was the question again?
It was about if a child comes in hungry and with bruises, like what should you do? And it's definitely report. And you wouldn't.
Is that an option?
One of the options was I had 4 options. It was call the parents, try to talk the child again, even though the child evaded you the first time, report to DS Department of Social Services, or talk to another teacher about it.
Wasn't it the parent first?
I'm with the report.
That's what I'm saying.
So because the child is coming in with hungry and bruises, you don't call home first.
Yeah, that was
because those could be coming from home.
Yeah, that's a safety.
Yeah, I want to say that. I was going to say like talk to like I would say talk to the principal and stuff, or like a guidance counselor.
That would be after you report because as a teacher, I think as a social worker, you have the duty to warn and report. So
yeah.
Right, it's stated by law that you're supposed to report any type of thing like that, because if something happens to that child and you knew about it, you're going
down.
Yeah, so it's DSS.
Also, heads up for your teaching, for any of your, I don't know if middle school has it, but for the high school learning and teaching guidance test, you have 4 or 3 response questions at the end that will require you to actually know some of the theories and methods, although I don't really know if I did answer those that well. But when I found out, they told me it was the last 4 questions were 25% of the exam. So I'm just sitting there going, why?
Yeah, the PLT is a little bit different with those open responses.
Kind of crazy.
But see, that one...
You wrote that part out?
Yeah, you'd have to type them out.
Like one of my questions was kind of like the one that Sam had. Mine wasn't multiple choice. Mine was open response. Another one of mine was about like OSHA. It was like safety. It was like a kid has a bleeding nose in your classroom. What steps would you take to like clean it up? That was one of my questions.
Oh, so it's not like a science question. Oh, so it's okay.
But that's only for high school that has to take that test.
Oh, okay.
Gotcha.
So it's kind of more like common sense kind of thing.
Yeah.
Okay, cause like I have friends, they're teachers, and they like cried when they failed a PLT. They're like, that was the hardest thing they took, and I was like, oh wow.
I would think I wouldn't want to miss like one small minor step. Like I'd be like, okay, you do this, but I don't know like how they would be checking it to the T.
I would say I think they give some grace on the open response questions, like especially knowing that you're an incoming teacher. I think they gave some grace on those answers because I know, like looking back in retrospect, I was like my answers were garbage. Like I was trying my best to like hit things that I knew, but like now if I had those questions, I would know. I would know what to do. So I do think because they know where you are in your teaching, like they know if you're already licensed or not. So I think they give you some grace when they say that you're not a licensed teacher yet.
Yeah, I think they would.
Like I feel like if I went and took it, they would be like, "Oh, ma'am, you're licensed, so you should know this answer."
Yeah. I think one of the other questions I had was more the open response ones was how would I help the kids who are already like at pretty much advanced above grade level? How would I provide an opportunity for them to like learn more? I was kind of stumped on that one because that's always the hard part. Because I think to myself, well, I have to keep the classroom fair because I don't want to like start differentiating. Okay, these kids are smart ones, these ones are grade level, then you guys are the below grade level. I don't want to start creating that kind of hierarchy, and that's one thing I try to avoid.
So one thing you can do in those situations, I think something I said, it was like along the lines of like having your high flyers be like the classroom leaders or having them like teach a class.
That's
like
what
you
I
have to
suggested.
Yeah, that's a good one. Having them teach. You can give them extension opportunities or something. I call them in my classroom beyonders. So and I offer it to everybody, but it's usually my highest flying students that get to a beyonder. Like it's something that you do beyond our extra work. So it's essentially not extra credit, it's essentially extension problems.
Okay.
You could also say like something like mixed level grouping. So you could put them in a mixed level
I did
group and
that.
have them be the leader. Yeah, that's the right answer.
I did something along like mixed level grouping, but I kind of did what you're like a beyond program too, kind of like that one. Except I threw in like something in there something like extra credit. I'm like, oh no. So he said like, great.
Some schools say no extra credit. My kids get extra credit every unit.
Yeah.
Every unit we got something.
But I try to
We're
make
having them make something. Also, if you talk about like, you can also talk about scaffolding assignments. So if you have like one learning goal in mind, but give different assignments to different kids, that's okay. So like I give this group a worksheet, but this group has like a color by number. So like if I'm doing moles, the conversions, I could give my high flyers maybe a whole worksheet that's like, you know, fix the problems, create problems. I could give another one like a specific set of problems that you have to solve to color this thing, as long as the end goal is the same.
Okay.
It's easier to do that in English than it is in science. So sometimes they'll call it like jigsaw reading, where they'll have like one group has a passage, one group has it broken down a little bit, another one might have it like already annotated.
Yeah, one was
you put them in mixed level groups and
yeah. The question had to do with an English class. I just did like I said reading groups, but what I'll do is I'll have the high flyer, the above of grade level kids. They'll have like their own group. The below average, but I'll cycle through because the largest group was the just at grade level. So I said I'd cycle through the some of the grade level people into the higher one in every book, or like every so often I'd rotate out and another group moved in. Then that group would another group would be in the normal group would be teaching the below level group. Yeah, so it's kind of like I'm doing all this. So I didn't know. I was like, so I was just thinking, like, am I doing this correctly? Because on the multiple choice, some of it was really common sense, and some of it was kind of, I don't know. This seems very like specific, hands-on, kind of nitpicky.
Yeah, I'm sure you did fine.
I'm hoping I did, because I have to wait 2 to 3 weeks, because this is the one test you don't get your score back immediately.
Yeah, because the writing part, it comes later.
So if you pass that one and then you fail the other one, then what?
You gotta take it again.
I take it again.
Before you start teaching as well?
Yes.
Oh wow.
That's crazy.
You have to have both.
Yeah,
you gotta have both.
Remember, I took mine a day apart, and my brain was so fried.
I bet. Oh my
I
goodness.
didn't do it like that.
Say that again.
I took my test a day apart. I took my science one the first day and then the PLT the next day. But I was about to graduate from college. It was like 2 weeks before senior week. I was like, I don't have any more time. I got to take a both.
I took a month separately at least, so I could just get some time studying some of the theories at least.
That's way better.
So we only have one test.
I gotta get this one first before I do that PLT.
Yeah, do the science one before you get to that PLT, because that's a little bit different and a bit of a weird one. Like some of it's just common sense. I'll ask you something really, really easy. Like, yes, this is the correct answer. You don't have to read the rest of them. You would know that, okay, this is obviously it. The other ones, it's just, how would you form like a teacher, like how would your shareholder or something like that form like a bond or community with them? I'm thinking, well, that's different.
Yeah, that one is.
Okay.
Yeah, those are the questions that I was getting on some of them, and I was thinking, okay, who are my shareholders and what am I doing?
Gotcha.
Yeah. So you'll have some like real. It's not really so much of a middle ground question to get. It's more of easy and hard. That's it.
Okay.
In my case.
Crazy. They should change that.
And they'll have a few theory ones.
They shouldn't make you have to retake the whole thing.
Well, we'll just see how I do in a couple weeks from now.
I have a question about the solar system. I guess this is about the solar. What is glaciers? That's probably not how you say that, but
like glaciers, like
ice. Sometimes ice.
Glaciers, and then hold on. Anna put it in the comment. It's spelled like glaciers, but it ain't glaciers.
Oh, is that the thing that's on the moon?
Yeah, I'm like, what?
Yeah, it like
It's spelled like glaciers, but hold on, let me see if I can find it.
I know you're talking about.
Trying to scroll through the chat.
Me too. Because they asked about seasons, like the Earth, Moon. How does
Thank you for answering my question.
Constellations?
Glaciers.
It's like something. It's like something on the moon. Like the moon got like some type of a glacier or something. I forgot what it was, but I know like 'cause they asked something like that on the exam edge thing too. But I know the answer for that one. It was like I forgot what it's called.
You was like, they asked about that?
Oh, when she was like galactic clusters?
Yeah, that yeah.
Oh, yeah.
Because I wrote that one down. I was like,
yeah, they asked about that. And it was in order, so you had to go from smallest to largest.
like, was it like universe, star, galaxy, cluster?
Yes.
Okay.
Yeah, and then it had like the stars, the solar system, planets. And I was like, what in the
Okay, when would the solar system be the last thing?
I thought stars would be the smallest.
I think star would be the smaller. So it's talking about the order of
size.
It's like the size order of basically like celestial beings. So it'd be like
the size of the stars. So are they talking about like? Did they talk about the sun or any kind of cycle or anything like that?
Yes, because it asks, you how winter, summer, spring, and fall. Wouldn't that be how the sun and something tilts on the thingy?
On the axis?
Seasons and tilt.
Yeah, wouldn't that be how? Okay,
the autumn and the vernal equinox.
They asked about supernova, like what is supernova best related to? It was something else about them darn solar system. Asteroids. Lord, I'll be done remember the whole 125 questions in a minute.
All right, well, I think I'm gonna head out now. Thank you for answering my questions.
Thank you, Sam. Thank you so much for your help.
No problem.
Thank
you, Sam.
All right, goodbye.
Oh Lord, you know what? It's one day at a time. I'm just gonna
say
the other day, I don't know if they asked this, but it brought back memories. But do they ask about the order of the planets?
No.
No,
okay, I was looking up that my mom.
But they talked about. You're not talking about the star cycle, are you?
No, she was talking about like the order of the planets.
No, when she was talking about the moon and all that stuff, it wasn't the star cycle, was it?
Not that I didn't really. That was the only one it had about the stars, like from smallest to largest.
Yeah.
Yeah, that was about it. About X. I'm trying to think of something else.
Okay.
I'm like supernova. I'm like, what? I heard of supernova, but
Is supernova when the stars is born?
When they die. I'm terrible at astronomy, so don't have me lie. But I did
I just made a list, so that I knew that was something else. And it's like, where would you be weightless? I put
You said what?
Where would you be weightless at? And it gave you.
It is the star cycle.
Is it the moon?
The moon, you would be almost weightless, almost.
Yeah. Chelsea.
Yes, ma'am.
It's talking about the star cycle.
Okay, make a note
and
of that.
it's talking about the nebulae and all that stuff and how the clouds are formed. Then you have the massive star. Then you have the red supergiant star or the neutron, and then it expands to the supernova.
Yeah, I think supernova is death. I was like, I'm pretty sure supernova is the end.
Death.
Yeah.
So it's the life and death of a star.
Types of stars.
Wait, Miss Simmons, is you talking about that first question she was talking about, or the supernova?
Yeah, because I'm like, wait a minute, that's the star cycle. Because you have two giant stars. You got the red giant star, and then you have the red super giant star.
Right. Yep, that's it. I remember asking about old age and birth. So yes, okay, that it was something else.
I have something on the screen that should kind of help too a little bit.
Yeah.
Get me questions from. That's what I want to know.
Me too. They asked about astronauts too.
Like,
trip this summer.
Like, do they just like come together and be like, okay, we're gonna ask this? Like, they don't be like, okay, what do kids learn?
But they said we supposed to know this on the level of students. Child, I feel like the student about
in all honesty, like every test, I mean, I'm just being honest regardless. Just like the ACT, the SAT, all of these tests, they notice that since we are in education, they're making it to the point to see, okay, you got this. How far can you go?
Pretty
But
much.
why? That's the thing. Why they making it so hard for teachers that they need teachers?
You didn't hear what I said. You didn't catch on to what I said.
I don't know how you
Look at your history.
Mm-hmm.
Look at your history. Look at your history. Look at your history. Think about it. When we went to go vote, we had to jump over hoops to go vote. And then when we did go, what would happen? And we would know the answer and everything. And then what would happen? They would add something else.
Pretty much.
Okay.
I see why they does call this general, because it is a lot of, they do ask like a mixture of questions. They ask something about magnets and unmagnetics and substances. I'm like, what?
Yeah. When you come to a magnet, I think you think about what's on the refrigerator. If it doesn't stick, then you know.
Oh, be quiet.
About how
I don't know what Tracy, my coworker told me this. She said that it's a difference between she said if you put right on your test, she said the test is easier.
I do have a question, Shauna.
Mm-hmm.
Okay, so like when they ask questions about like resist, because I was looking at the videos on the Khan Academy. I was looking at it early this morning, like 6 o'clock in the morning. And, like Ohm law, is that like, because I know they would have like
with 4 items.
like a rectangle with like a ziggly line. Like is that the same thing as the Ohm's law, or is that like something different?
Ohm's law measures how much resistance is in a circuit. So it's going to be very similar. So when you're talking about the squiggly line and stuff, that's talking about series and parallel circuit. So what I'm going to do
about that
is take session 3, and I'm going to change that from what I had before, like the vectors and the scalars, and I'm going to change that to all circuits.
Yes.
So that'll be next